So this is lesson 7.2, solving systems with substitution. So problem number 6, I have two equations in the system. What I'm going to do is I'm going to use the negative 3n minus 6, and I'm going to substitute it into the second equation for my value of c of n. So then I'm going to rewrite this equation. So I have negative 3n minus 6 equals n minus 4. And I'm going to solve, add 4 to both sides. So negative 3n minus 2 equals n plus 3n to both sides. Negative 2 equals 4n, divide both sides by 4. So n equals negative 1/2. All right, so we need to take this answer and substitute it back in and solve for c of n. So I have c of n equals negative 1/2 minus 4. That means c of n equals negative 4.5. So the answers to this system, negative 1/2, negative 4.5. Now the directions say to do a check, so we need to do that. So the check, remember the solutions were negative 1/2, negative 4.5. So I need to check both equations. C of n equals negative 3n minus 6, and c of n equals n minus 4. So negative 4.5 equals negative 3 times a negative 1/2 minus 6. Negative 4.5 equals 1.5 minus 6. Negative 4.5 equals negative 4.5. That's good. Over here, c of n is negative 4.5 equals negative 1/2 minus 4, and those check out as well. So those are good. All right, for number 9, I just like number 6, I'm going to substitute in 6g minus 4 for h. So rewrite the equation. So I have 6g minus 4 equals 2g, negative 2g plus 28. Solve. So I'm going to add 2g to both sides. 8g minus 4 equals 28. Add 4 to both sides. 8g equals 32. Divide by 8. So g equals 4. I'm going to take that value, g equals 4, and I'm going to plug it in right here to solve for h. h equals negative 2 times 4 plus 28. h equals negative 8 plus 28. h equals 20. Now remember, when you're using the substitution method, you can take your answer when you isolate the first variable or solve for the first variable. You can plug that back into either one of the original equations. It doesn't matter which one you choose. Excuse me. So the solution here is 4 and 20. Okay. Number 12. I'm going to take the 3d minus 27 and substitute it in for c. So when I rewrite that, I have 4d plus 10 times the quantity 3D minus 27 equals 120. I need to distribute. So now I have 4D plus 30D minus 270 equals 120. 4D plus 30D is 34D. I'm going to add 270 to both sides. So 34D equals 390. Divide both sides by 34. So D equals 195 over 17. Now I know you're freaking out right now because that's a horrible fraction, but go with it, okay? So we're going to take this value and we're going to substitute it in right here for D. So when we do that, we have that C C equals 3 times 195 over 17 minus 27. So C equals 585 over 17 minus 27 times 17. You need to figure that out. You want to put that as a fraction. You want 27 to be put as a fraction over 17. So 27 times 17 is 459. So now I'm going to subtract the two of those. So 585 minus 459 is 126. So I have 126 over 17. So that is the solution to this ordered pair, 120, or this system, 126 over 17 and 195 over 17. And because this one has such odd fractions, I think we should check that. So again, the solution is 126 over 17 and 195 over 17. All right, so let's check. So C, which is 126 over 17, equals 3 times the quantity 195 over 17 minus 27. That's my first equation. And my second equation is 4 times 195 over 17 plus 10 times 126 over 17 equals 120. All right, so let's do this one first. 126 over 17. So the easiest way to get rid of these fractions is to multiply everything by 17. So when I do that, I have 126 equals 585 minus, what did we say, 27 times 17 was 544, 459. All right. And you'll see that 585 minus 459 does equal 126. So that checks out. For the second one, if we do the same thing, multiply everything over here by 17, we come up with 4 times 195 is... All right, 4 times 195, we're multiplying everything by 17. So when I multiply this by 17, this goes away. This by 17, it goes away. 120 times 17 equals 2040. 4 times 195 is 780 plus 126 times 10 is just adding a 1260, and that does equal 240. So they check good. Okay. All right, number 17. Again, I'm going to take this value and substitute it in for y. So when I rewrite it, I have 7x minus 8 times the quantity negative 2x plus 9 equals 112. 7x, I'm going to distribute that negative 8. Negative 8 times the negative 2x is plus 16x. Negative 8 times a positive 9 is minus 72 equals 112. Combine like terms, 23x minus 72 equals 112. Add 72 to both sides. 23x equals 184. Divide both sides by 23. X equals 184 over 23. Again, a nice looking fraction there. So we're going to take that value and we're going to substitute it in to this. 7 times the quantity 184 over 23 minus 8y equals 112. Okay, so I'm going to multiply everything by 23. So I have 7 times 184 is, let's see, 7 times 184 is 1,288. That cancels out. 8 times 23 is, 8 times 3 is 4. 184, and 112 times 23 is
2,576.
2,576. Okay, so I'm going to subtract 1,288 from both sides. So I have negative 184y equals 288. Divide both sides by 184. So y equals, I can reduce that by 2. I can actually reduce that by 4. That'll be 72 over let's see, 4 will go into 18 4 times, 46, which reduces to 36 over 23.